This is how we managed to deflect an asteroid. DART mission. For the first time in history, an asteroid has been deflected. No, it's not a science fiction movie. It's the DART mission, a spacecraft that intentionally collided with an asteroid to change its orbit. Do you want to know how it did it and what possible consequences it could bring to Earth? Let's start. On September 26th of this year, NASA put the DART mission to the test. This space mission consisted of a 610 kilogram spacecraft that did not have any payload. That is, unlike other missions such as space exploration probes that carry several essential scientific instruments, the DART mission had as its sole objective to hit an asteroid. In addition to the spacecraft, the mission also had on board a small CubeSat. These are small cubic ships that are intended to monitor a particular event. In this case, the CubeSat installed by the Italian Space Agency had the purpose of trying to acquire images of the impact and ejecta as it passed by the asteroid, and then sends that information back to Earth. The DART mission took off on November 24, 2021 from the Vandenberg Space Base in the United States on board a Falcon 9 and traveled approximately 1 million kilometers for 1 year to reach its target, the binary asteroid Didymos. Asteroid system. The target of the DART mission is the asteroid Dimorphos, a small asteroid of 170 meters in diameter that orbits around Didymos, an asteroid of 780 meters in diameter. Both asteroids are classified as binary asteroids, since Dimorphos orbits around Didymos every 11 days as if it were its moon. Why was this asteroid chosen and not any other? First, by deflecting this asteroid, changes in its velocity can be measured by observing as Dimorphos passes in front of Didymos, causing a drop in light that can be seen by ground-based telescopes and accurately measuring how much it has deviated. Dimorphos was also chosen for its proper size. It is in the size range of Apollo-type asteroids, which are the most dangerous for the Earth in the short term. We will discuss this later. It was also chosen because the binary system was relatively close to Earth at this time. And finally, and the most important reason, is that by slightly changing the trajectory of Dimorphos, it will continue to orbit around Didymos. That is, it will continue within the binary asteroid system. So changing its orbit does not pose a risk to the Earth. In fact, according to the words of the Planetary Defense Coordination Office, this binary system is perfect for testing planetary defense technology and serves as a laboratory where we can experiment without putting our planet at risk. Moment of truth. Before impacting the asteroid Dimorphos, the DART spacecraft had to travel an enormous distance from Earth to its encounter with the asteroid for a year. Although this journey seems long, it's within the range where most of the asteroids that pose a danger to the Earth are located. On September 26, the DART spacecraft reached its destination. On Earth, various telescopes were monitoring the situation to capture as much information as possible. The solar panels were in the direction, the rockets were at full power, and the point of impact was marked. The spacecraft approached quickly and finally hit the asteroid by firing off numerous material that shot out into space and could be seen with Earth's telescopes. To this day, we still do not know if that impact will be enough to change the orbit of the asteroid. For this, we will have to wait a couple of weeks. The DART impactor had its primary objective to delay the speed of the asteroid a little. Not much, just a little. But why do you want to do this? Many may not know this, but this is one of the most effective ways to deflect an asteroid. If we discover an asteroid heading to Earth, we only have to divert it a little, either delaying it or rushing it into its orbit around the Sun, so that when it reaches the meeting point of the Earth, they don't meet. This is what we know as an asteroid redirection mission. In the case of the DART mission, the objective is to collide head-on with Dimorphos to reduce a little, but very, very, very little, its speed. In this way, over several orbits accumulated for weeks, months, or years, its final trajectory compared to before the impact will be very different. This is the same as what we would do to deflect an asteroid heading for Earth. Are these types of asteroids a danger? Didymos is classified as an NEO asteroid. NEOs, near-Earth objects, are the asteroids that cross the Earth's orbit from time to time. The binary system of Didymos is an Apollo-type asteroid. These are a type of asteroids that are within the orbit of the Earth, and from time to time come very close to our planet. According to the most conservative estimates, there are currently about 70 million of these asteroids orbiting close to the Earth. But rest assured, most of these asteroids are the size of a house, which is not exactly good news since the Chelyabinsk bolide that hit Russia in 2013 was just an Apollo-type asteroid, and we all know the damage it caused. Fortunately, none of these asteroids are on a collision course with Earth, or so we believe. Since the sad and disturbing reality is that today it is estimated that we still have to discover several thousands of these types of asteroids, let's hope that none of those that we have not yet discovered will head to Earth anytime soon. Can an asteroid of this size destroy the world? The asteroid Dimorphos measures 170 meters in diameter, and Didymos 780 meters in diameter. So it is impossible for either of them to destroy the planet. However, if an asteroid 170 meters in diameter like Dimorphos were to fall onto the Earth, it could quickly destroy several countries, claiming millions of lives. If an asteroid the size of Didymos were to hit the Earth, it could destroy a continent and cause environmental seriousness worldwide. As you can see, asteroids of these sizes cannot destroy the planet, but they can destroy a part of it, causing severe damage to the world and eradicating many living things. Want to know what the worst part is? The worst part is that the asteroids that astronomers are most concerned about are just these. Observational astronomers estimate that all large asteroids like Didymos have already been discovered and that there are no more to discover. This is because asteroid discovery graphs indicate that when we started monitoring the sky for asteroids in the 40s, we initially found many large asteroids like Didymos. Still, as time has passed, we have stopped discovering giant asteroids, and each time we continue to find small asteroids. Even though our observational technology, such as space telescopes and astronomical observatories, has improved considerably, we are no longer finding giant asteroids. The simplest explanation for this is that we have already found them all. However, the same is not true of small asteroids, which continue to appear. While small asteroids do not pose a threat to all life on Earth, they are a threat to small regions of Earth. Most of these asteroids still being discovered are smaller than Dimorphos, so managing to deflect this asteroid is an unprecedented achievement for planetary defense. If we can deflect Dimorphos, we will also be able to deflect a potentially dangerous asteroid heading for Earth in the coming years. A big step for the defense of the world. This is not the first time in history that an object created by the human race collides with an asteroid. The first attempt to test this maneuver was with the Deep Impact spacecraft in 2005, which launched an impact that hit the nucleus of Comet Tempel 1. While this impact failed to deflect the comet's trajectory, it served as part of the DART mission. Suppose the technology for planetary defense continues to advance as it has so far. In that case, the most certain thing is that in the coming years, we will continue to see more missions like this that help us prepare and defend ourselves from space threats, so that the same thing that happened to the dinosaurs does not happen to us 65 million years ago.